Hello viewers, welcome back to my channel, and in this video we're going to solve a triple integral in spherical coordinate problem. So I have evaluate triple integral of 10xc plus 3dv, and I have the region E here, and where that E is the region portion of x squared plus y squared plus z squared equals 16 with z greater than or equal to 0. So first of all, if this is your first time visiting this channel, kindly subscribe, and also you watch this video to the end and you like as well. So when you talk about spherical coordinates, and also when you talk about triple integral, and you also add the two of them together, all that means is there are some problems, or there are some triple integral problems which you can't use the Cartesian form to solve. So we use the spherical coordinate to make things simpler. And in the spherical coordinates, let's talk more about the spherical coordinates, what the spherical coordinates is all about. So if I have my 3D like this, I'm going to have here to be my z, I'm going to have here to be my x, I'm going to have here as my y. So if I have a point in space here, say P, so this point here can have the representation or its coordinates in the spherical coordinates will be defined by a certain parameters. So first of all, I'm going to draw a vertical broken lines here, and I'll also draw a straight broken lines here. So the distance of this point from this origin here is what we call the rho. So we have rho here. Then at the base here, if I'm to draw a straight line through this, at the base here, the distance from this base from the xy plane is what we call the radius. The radius. Then also I have an angle here, that is the angle this radius makes with the x-axis, say theta, as well as the angle this rho, which rho is the distance of P from the origin here. So that place I'm going to have another angle called phi. So having these parameters here, the spherical coordinates are simply, I have my rho, comma, my theta, then my phi. So if I get these three parameters, then I'll say these coordinates are spherical coordinates. So if I'm being given any integral problem where I have xyz, I'm supposed to convert the xyz to the polar or cylindrical or spherical coordinate, but in this context we're using the spherical coordinate. So what's the relationship between x, y, and z with the polar coordinate, with the spherical coordinate? So let me quickly go straight. I'm going to have, so at this point here, I know that my r here is simply rho sine phi, and I know that, so r is simply rho sine phi. Then let me make here, so this place is the P, and I'm having this place is our z, the z line. So our z is also equal to rho cos phi, and our theta, which is the theta here, still remains the tan inverse of y over x. So these are just the representation of the polar coordinates, just representation of the polar coordinates. So in all, if you have x in the Cartesian, x is simply equal to rho sine phi cos theta. Then if you see y is also equal to rho sine phi sine theta. So these are some of the substitutions you're going to make whenever you are dealing with the spherical coordinate. Then your z is simply rho cos phi. So take notes. So the next thing we're going to do is, let's move straight solving our problem here. Now we are going to convert this x and z in our function here to the cylindrical coordinates. So I'm going to have my triple integral. I'll have my e here, and I'm going to have my 10 open brackets. So the x there is going to be rho sine phi cos theta, then multiplying my z, which is rho cos phi. So once I get this, plus 3 here, then the general notation for integral in the spherical coordinates, you are going to add rho squared, then sine phi dz, sorry, the rho, then the theta, then the phi. So now we have all our parameters converted into the spherical coordinates. What you are left with is finding the limit points, the upper and lower limit for each of the integral. So how do we do that? They gave us that it's between x squared plus y squared plus z squared is equal to 16. So the region portion of this, where z is greater than or equal to 0. So if you want to find the limit for your integrals, the best way is to make some kind of sketch of how this is drawn in the 3D space. So if I have my 3D space back again, like this, where here is my z, here is my y, here is my x, and I want to represent this. This is a sphere with radius, that's going to be 4. It's a sphere with radius 4. So when we say z is greater than or equal to 0, it means that we're going to have a region above the positive xy plane. So it's actually this region. It has nothing to do with the negative side. So I'm going to have a sphere which is going to be halfway like this. So it's actually a sphere. So a sphere like this. So this sphere is just halfway and it doesn't go to the negative side. So that is how the region portion is going to help you determine the limits for your integral. Now, one asks, what do I need for the limits? Now, I'm integrating with respect to the rho, the theta, and the phi. So first of all, I need to find the rho. That is, rho is simply your point in space which turns around to create our solid figure. So you can see that from here, the rho is actually the point here. When you draw this imaginary line here, when you skew it around, it's going to help us get our perfect sphere. So if the distance from here to here, that is going to determine this whole boundary. So in effect, this rho is more or less like our radius in the 3D space. So if you want to find a radius with which you are going to draw this sphere in 3D space, that's what we call the rho. And from these formulas, if you square x squared plus y squared plus z squared, you realize that you'll be getting rho squared. So here in this formula, we're going to represent this whole stuff with what? Rho squared is equal to 16. Therefore, our rho is going to be 4. When we're dealing with distance, we ignore the negative side. So rho is 4. So rho is going to start from the origin and reach 4. So our sphere is going to lie here, which is 4. It's going to lie here. It's going to skew around. So from here to here is going to be 4. And this 4 will skew around to give us our spherical, let's say a half sphere. So this, as I'm having here, so I'm going to have my interval for p to be greater than or equal to 0 or less than or equal to 4. So I'm done for p side. So let's say it's rho. So I'm done for the rho side. The next one I'm going to find is my theta. Now when you say theta, as I said, theta is the angle this base here is making with the xy plane. So if you want to find the angle this base is making with the xy plane, what you need to do is you realize that the base here, there is a circle. If you are to stand up and to see down, all this part will collapse, and all that you'll be seeing is just a circle which has fallen on the XY plane. And you realize that this angle is going to skew around. It's going to skew around. So you're going to get something like a full circle. Yes, you're going to get a full circle. So I'm going to get 0 less than or equal to theta less than or equal to what? 2 pi. Then finally, I need my phi. How am I going to get phi? So as I said, the phi is the angle with which this radius in the 3D space, which I call rho, is going to make with our xy plane here, and that is what is going to skew around. So in effect, this radius is making an angle of 90 with the xy plane, so it's making an angle of 90 with this, so that when we skew it around, we're going to get a hemisphere. But if it happens to be 180, then you're going to get a full solid sphere. So since this is a hemisphere, you're going to choose the interval 0 less than or equal to phi less than or equal to what? Pi on 2. So the maximum phi can have is from 0 to pi. That is when you get a full hemisphere. So this becomes our limit point that we're going to use to solve our integral. So I'm going to have my integral, the phi is the outer, so we're going to have 0 pi on 2. Then I'm going to have another one, 0 to 2 pi. Then I'll come 0 to 4. Then I expand this. So for this side, what am I having here? So I'm going to multiply whatever I'm having here within the bracket first. So I'm going to get 10 rho. So 10 here, then this row and this row will multiply. So 10 rho squared. Then once I get that, I'm going to get sine phi, cos theta, then plus 3, and this whole thing is being multiplied by rho squared here, sine phi, then the rho, the theta, the phi. So this is our general integral with our upper and limit point present. The next to do is for you to be careful with the computations. You have to be very careful when you are computing this. You have to be very, very careful. So what we're going to do is we're going to still multiply this. So I'm going to have my integral here, 0 to pi on 2. Then integral 0 to 2 pi, integral 0 to 4 of, so here 10 still comes out. Then I'm going to get rho cube sine squared phi cos theta plus 3 rho squared sine phi, the rho, the theta, the phi. So since my inner function is rho, the rho, I'm going to integrate with respect to what? Rho first. So once I get that, I move on to the outer, the next immediate outer here. So if I integrate with respect to rho, you realize I'm going to get what? I'm going to integrate with respect to rho. So with my first part, you realize I'm going to get my function to be, if you integrate this rho to the power 3, so I'm going to get rho to the power 4 over 4, whilst I have 10 here. Then once I get that, let me see. So from here, the rho was rho squared when I was multiplying, so here is supposed to be rho to the power 4 actually. So since that place is rho to the power 4, then I'm going to get rho to the power 5 here, then I'm going to get 5 here. So I come sine squared phi cos theta plus 3 rho squared sine phi d rho d theta d phi. So once I get this, I move forward, and here I'm going to get 2 rho to the power 5 sine squared phi cos theta plus, when I integrate this plus, I'm going to get rho cube over 3, and that 3 is going to cancel this 3, so rho cube sine rho d. So now the d rho has to leave because we've integrated respect to rho. So what we are supposed to do is I'll introduce my 0 to 4, and here will be the theta, the what, phi. So wherever I see rho, I'm going to put what, 4, and I'll put 0. But I realize that when I put 0 at any of them, I'm going to get everything vanishing. So I'm interested in putting the 4 rather. So I'm going to put 4 inside wherever I see rho. So this side, I'm going to have integral 0 to pi, then integral 0 pi on 2. So if I have rho here, I'm going to put 4 there. So 2 multiplying 4 to the power 5. That is giving me 2048 sine squared rho, sine squared phi, then cos phi cos theta plus, this becomes 4 to the power 3, and that is giving me 64, then sine rho d theta d phi. So gradually we're moving inside, and here I have my 0 to 2 pi, 0 to pi on 2, right? Yeah. So at this point, what I'm going to do is I'm going to integrate with respect to d theta. So I have only one theta here, and I'm going to get all these stuffs remaining as a constant. So I'm going to get 2048 sine squared phi, and this place is going to be cos phi, but if you integrate cos theta, you're going to get sine theta plus 64 sine phi. Then since we don't have any the theta term, I'm going to have theta right here, theta right here. So when I have this, here will be 0 to 2 pi, then here will be my dp, sorry, d phi here. Then I'm going to have 0 to pi on 2 here. So at this point, if I put 0 inside, let's see, if I put 2 pi, sine 2 pi, what is sine 2 pi? Sine 360, I'm going to get 0. So if I put 2 pi inside, I'm going to get 0. If I put 0 for this side, everything will be 0. So I'm going to focus on this side. So if I put 2 pi inside, here is pi. Here I'm having only the theta here. So if I put it, I'm going to get 64 by 2 pi sine phi, then minus 64 multiplying 0 sine phi like this. Then when I evaluate, I'm going to get 128 pi sine phi. Since this will go 0, then d phi, then I bring 0 to pi on 2. So now I'm left with only phi. So if I'm to further integrate this, if I integrate this with respect to phi, you know this is going to be negative. So negative cos phi. So 128, then I have my pi here, then this is going to give me negative cos phi. I introduce my 0 pi on 2. So at this point, what am I getting? If I put pi on 2, what is pi on 2 here? Pi on 2 is going to give me, so 128 pi, open brackets, negative, pi on 2 is 90, I'm going to get 0 minus negative cos 0, where cos 0 is 1. So 128 pi, then I'll have negative